Today's lesson is going to be on how to find determinants of a matrix. First off, you have to have a square matrix to find the determinant. A determinant is a real number associated with a square matrix. So, for example, what we're talking about here, as you can see, is how to find the determinant of a 2 by 2 matrix. Finding the determinant of a 2 by 2 matrix is really not too bad. You are simply just taking the product of the downhill diagonal entries minus the product of the uphill diagonal entries. What I mean by that is, as you can see on the screen here, I've just got a generic 2 by 2 matrix where we've got A, B, C, D. So reading from left to right, the downhill diagonal would be A, D. Right, because if you were going from left to right, that is in the negative direction, that is downhill. So you are taking the downhill diagonal of AD minus the uphill diagonal of CB. That literally is your formula for determinant of a 2 by 2 matrix. It is taking AD minus CB. And notation for determinant is simply just DET. So DET of this matrix, the determinant of this matrix, would be AD minus CB. So for a quick real example, let's say I asked you to find the determinant of the matrix 7, 2, 2, 3. Well, in that case, the downhill diagonal would be 7 times 3, and the uphill diagonal would be 2 times 2. So you would need to take 7 times 3 minus 2 times 2. 7 times 3 is 21. 2 times 2 is 4. 21 minus 4 is 17. So that would be your determinant. Do recognize the determinant really is just a number. This is not a 1 by 1 matrix of 17. It's just a number. Okay, so the determinant here would be 17. Now let's talk about how to find the determinant of a 3 by 3 matrix. This is going to be a little bit more involved, as you would expect with it being a larger matrix. So there's kind of two steps to this. Your first step for finding the determinant of a 3 by 3 matrix is you want to take the first two columns and repeat them to the right. Meaning you'll kind of take the 3 by 3 matrix and almost kind of turn it into a 3 by 5. So like in this generic example down here with a 3 by 3 matrix of A, B, C, D, E, F, G, H, I, you would take the first two columns of A, D, G, and B, E, H, and you rewrite them to the right there. See how this has kind of turned it into more of a 3 by 5 than a 3 by 3? After you have done that, now you're on to doing the downhills minus uphills. Now it is still downhill minus uphill, the same as 2 by 2 was. The catch is, with a 3 by 3 matrix, now kind of a 3 by 5, we are going to have multiple downhill diagonals and multiple uphill diagonals. Now the easy way to remember it is it's the rule of 3. This is a 3 by 3 matrix that we're finding the determinant of. There should be 3 downhill diagonals. There should be 3 uphill diagonals. Also, each of those diagonals should have 3 numbers inside them. Everything is 3s. So, if we want to start with our downhills, we have 3 downhills that have 3 numbers in them. So that would be A, E, I. That would be B, F, G. And that would be C, D, H. What we're going to do is we multiply the numbers within each diagonal and then add those products together. Meaning you would be taking A times E times I and adding that to B times F times G, and adding that to C times D times H. And all of that together will give you one number for your downhills. When you get that one number, you will be taking that number minus the one number you get from your uphills. Again, we should have 3 uphills that have 3 numbers each. So that would be G, E, C. That would be H, F, A. And that would be I, D, B. So again, You're multiplying those three numbers within each diagonal together and adding them to the other products. So GEC plus HFA plus IDB. And then after you've gotten one number for your downhill and one number for your uphill, you subtract them. That's how you find the determinant of a 3 by 3. So for an example, let's say I gave you this 3 by 3 matrix of 4, 3, 1, 5, negative 7, 0, and 1, negative 2, positive 2. Our first step would be we need to rewrite the first two columns off to the right, or repeat the first two columns to the right. So that would be 4, 5, 1, and 3, negative 7, negative 2. First thing I would want to do is find my downhill diagonals. Remember, there should be 3 of those with 3 numbers each. So it looks like that would be 4, negative 7, 2, 3, 0, 1, and 1, 5, negative 2. So that means I've got 4 times negative 7 times 2 plus 3 times 0 times 1 plus 1 times 5 times negative 2. And all of that together will give me my one number for my downhill diagonals. I'm going to be taking that minus what I get from my uphills. Again, I should be getting 3 uphill diagonals that each have 3 numbers in them. So it looks like 1 would be 1, negative 7, 1. Looks like another would be negative 2, 0, 4. And another would be 2, 5, 3. So I've got 1 times negative 7 times 1 plus negative 2 times 0 times 4 plus 2 times 5 times 3. And so now I want to get one number for my downhills and one number for my uphills. So 4 times negative 7 times 2. 4 times negative 7 is negative 28. Negative 28 times 2 is negative 56. 3 times 0 times 1 is just 0. It's always nice when 0 is part of that. It makes it a lot easier. 1 times 5 is 5, and 5 times negative 2 would give us a negative 10. In our uphills, 1 times negative 7 times 1 is negative 7. Again, we have negative 2 times a 0 times 4, so it's just 0. 2 times 5 is 10, and 10 times 3 would give us 30. Negative 56 plus 0 minus 10 would be negative 66, and that will be minus negative 7 plus 30, which would give us 23. That means we are taking negative 66 minus 23, which would give us negative 89. So that would be our determinant.